Hey guys, here's an aspire to do lesson called inverse functions. If you're watching this, awesome, great job, you rock for going above and beyond. And here we're going to find the inverse of linear functions. So it sounds pretty complex the first time you hear it, and it's really not bad at all. But let's let f be a function, okay? So like f of x is the function. So now, if there's another function that will match up the outputs and inputs whenever f pairs with the inputs and outputs, all right? So if there's another function that the outputs are the inputs, when f of x's inputs become the outputs, like they switch places, notice the switch, then those two are inverse functions, all right? Doing a guess and check would be crazy. That would be really, really nearly impossible to figure out the inverse functions if you're like, oh, let me see if this output matches with this input and this input matches without output, all right? So there's a much simpler way to identify and create these inverse functions. To do this, to find the inverse of a linear function, all right, there's a couple different steps. The first thing we want to do is replace f of x with y. All right, just makes it much simpler to do that. All right, and after we do that, we're going to take the x and the y, and they're going to swap places. Okay. Then we're going to solve for y. Lastly, once we have that, we're going to replace the new y with f with a -1 as the exponent. And that -1, you'll learn much more as maybe not even this year, but this will lead you maybe Algebra 2 stuff. That stands for the inverse of, all right? When you have a -1 as an exponent. So once you solve the second equation for y, you then replace it. You don't want to replace it with f of x because that would be the same, or not even g of x even. You want to replace it with f -1 of x equals, and there you have your inverse function. All right, so let's walk through one of these step by step. Okay, let's find the inverse of f of x equals -2x plus 4. So this is just a regular function. First thing we're going to do is we're going to replace f of x with y. I'll put myself up here now. Pretty easy. Next, we're going to switch the x and the y. So the x and the y are going to switch places. So now it becomes x equals -2y plus 4. Okay, see that? Now, thirdly, we're going to solve that equation for y. So to solve it for y, I need to identify, there it is. I need to first subtract 4. So I have x minus 4 will equal -2y. My next step would be dividing by -2. Divide this whole side by -2. That cancels out. I'm left with y equals x over -2. Well, the coefficient really is a 1 here. So what I would do is I would make that -1/2 x, and then -4 over -2. The two negatives will make a positive. 4 divided by 2 is 2. So when I solve for y, I get -1/2 x plus 2 equals y. And lastly, I'm going to write it properly. Oh, look at that fancy. F of -1 of x will equal -1/2 x plus 2. So what that means, this function and my original function would have, if I were to plug an input in for my original, I would get an output. And then if I would take that output and plug it as an input in my inverse function, it would become the output of that function. All right? Mathematically interesting? Maybe. All right? Why don't you try this one? Find the inverse of f of x equals 4x minus 1. I did the first step for you. Y equals 4x minus 2. I'm going to give you some time, give you some choices to select what answer you think is right, and have at it. All right, hopefully what you did next was you swap the x and the y, right? Then you solve for y by adding 2, dividing by 4. So I kind of made it a little simpler over here. Y equals 1/4 x plus 1/2. And the final step is going to be just replacing this y with f of negative 1 of x. And those are inverse functions, okay? Nothing we're really going to dive into deep, but that's why this is an Aspire to Do lesson. It goes in a little bit more in depth than we absolutely need to. If you want to do some practice on this, there is a Khan Academy, Finding Inverses of Linear Functions. Thanks for watching.